Earth beautiful, alive, serene. But it was not always this way. Its skies once swirled with poison, the air was heavy, filled with gases no creature could breathe. Oceans boiled, volcanoes raged, a world where life should never have taken root. And yet, it did. Something hidden, something small, something no eye could see. It began in silence, in the depths, where darkness pressed against the unknown. And from that silence, everything changed. This is the story of Earth, how the impossible became home, and much more. From space, it glows like a marble of blue and white. Oceans shimmer, clouds drift, continents stretch in patterns that seem both familiar and eternal. Yet this beauty is fragile. A thin film of air clings to the surface, thinner than the skin of an apple compared to the whole fruit. Without it, there would be no sound, no warmth, no life. Beneath our feet, the ground feels solid, permanent, but the truth is far different. Under the crust, molten rock flows, restless and alive. Entire continents drift like rafts, colliding, splitting, reshaping the surface of our planet. Mountains rise, valleys sink, Earth is in constant motion, even when it seems still. The oceans cover more than 70% of Earth. Vast, deep and ancient, they are home to most of the life that has ever existed. From tiny plankton to the great blue whale, life flourishes in the water. These oceans also act as Earth's memory. They store heat, shape weather, and drive the great cycles of climate that have allowed civilizations to rise and fall. Without the seas, Earth would be barren, a desert world. Above the oceans and land, the atmosphere stretches into the sky, invisible yet vital. It shields us from radiation, burns up meteors before they strike, and creates the gentle weather that shapes our days. The air itself is a delicate mixture, 78% nitrogen, 21% oxygen, with small traces of argon and carbon dioxide, a fragile recipe that allows every breath we take. Scientists believe this balance was not always here. Billions of years ago, Earth's atmosphere was toxic. Volcanoes filled the sky with carbon dioxide, methane, and ammonia. There was no oxygen. The planet was hostile, a place where life seemed impossible. But deep in the oceans, tiny organisms began to change everything. They learned to use sunlight, photosynthesis. Slowly, they released oxygen into the air. Over millions of years, Earth transformed. The skies cleared, oxygen built up, life expanded. Earth's forests are often called the lungs of the planet. From the Amazon rainforest to the woods of the north, billions of trees breathe in carbon dioxide and release oxygen. They cool the air, shelter countless species, and stabilize the soil beneath them. But forests are only part of the story. Microscopic plankton in the ocean produce even more oxygen than all the forests combined. Life itself maintains the air that life depends on. Our fragile shield does more than allow breathing. It creates the blue sky. As sunlight enters, tiny molecules scatter the shorter blue wavelengths, painting the heavens in color. Without an atmosphere, the sky would be black, even at noon. With it, sunsets glow orange and red. Clouds drift in shapes that change by the hour. Rain falls, snow blankets the ground, storms rage and then fade away. The weather is Earth's endless heartbeat. From space, Earth looks calm, silent. But up close, the planet is restless. Volcanoes erupt with the power of thousands of nuclear bombs. Earthquakes shift entire landscapes in seconds. Storms with winds over 200 miles per hour tear across oceans and land. And yet, through this chaos, life persists. In fact, life thrives because of it. Volcanoes create new land. Storms carry water across continents. Even destruction feeds creation. Scientists call Earth the Goldilocks planet. Not too hot, not too cold. Positioned just the right distance from the sun. Close enough to keep liquid water, but far enough to avoid being scorched. This delicate balance makes Earth unique among the worlds we know. Venus is too hot, Mars is too cold. But here, oceans remain liquid, and temperatures allow life in countless forms. The more we study Earth, the more fragile it seems. A shift of just a few degrees in global temperature can reshape entire ecosystems. Ice caps melt, seas rise, forests burn. Yet for billions of years, Earth has balanced itself, adjusting, adapting, continuing to support life. Scientists study ice cores, tree rings, and ancient sediments to trace these cycles. The planet has endured ice ages, asteroid strikes, and mass extinctions, and still, it recovers. The story of Earth is also the story of us. For over 200,000 years, humans have walked this planet. We built fires, formed language, and eventually cities. We learned to cross oceans, climb mountains, and peer into the stars. Every tool, every culture, every dream has been shaped by this planet beneath our feet. Without Earth's fragile balance, none of it would exist. Looking back from space, astronauts often describe a feeling known as the overview effect. They see the Earth suspended in blackness, small and glowing, no borders, no divisions, just one world, alive, delicate, and alone. Many describe it as life-changing, a reminder that everything we know, every person, every memory is here on this fragile sphere. The Earth is not permanent. One day the sun will expand, oceans will boil, and this planet will change forever. But for now, it is alive, vibrant, breathing, a rare jewel in a silent universe. And as we drift deeper into the story of space, we carry this thought: Earth is where life begins, but perhaps not where it ends. Next, we look upward, to the air itself, the invisible shield that makes life possible, the atmosphere, the air that breathes our atmosphere, invisible, yet everything. It clings to our planet like a veil, thin, fragile, but powerful enough to shape oceans, forests, and skies. Without it, Earth would be silent, frozen, a barren rock adrift in the void. With it, life breathes. The atmosphere is mostly nitrogen, about 78%. Oxygen, the gas we depend on, makes up just 21%. The rest, a scattering of argon, carbon dioxide, neon, and traces of other elements. An invisible recipe, precise, balanced, perfect for life. Layers rise above us, each one with its own character, its own role. Closest to the ground, the troposphere. This is where we live, where clouds form, where storms rage. It stretches only about 10 kilometers above our heads, yet it holds almost all the air we breathe. Without it, rain would never fall, winds would never blow, and the sound of your voice would vanish into silence. Above it lies the stratosphere, calm, ordered. Here, the ozone layer spreads like a shield. Ozone absorbs harmful ultraviolet rays from the sun. Without this shield, skin would burn, crops would wither, oceans would boil with radiation. Life would never have flourished. Higher still, the mesosphere, a cold frontier, the place where meteors burn. Night after night, fragments of rock collide with this thin air. They glow, they streak, they vanish. Shooting stars, an atmospheric defense system, unseen but tireless. Then the thermosphere. Here, the air is so thin that molecules drift apart, yet temperatures soar, heated by the sun's energetic radiation. This is where the auroras dance. Curtains of green and violet light, streams of solar wind colliding with Earth's magnetic shield. A cosmic ballet, performed only in the skies. Above all lies the exosphere, the edge of space. No boundary, only fading air. Molecules slip away, drifting into the void. The atmosphere slowly dissolves into nothingness. The air is not static, it moves, shifts, it has shaped history. Sailors once depended on steady trade winds to cross oceans. Civilizations grew where monsoons watered the land. Wars were won or lost depending on storms, on winds, on invisible currents. And yet for most of history, people did not know air even had weight. In the 17th century, Italian scientist Evangelista Torricelli built the first barometer. He proved that air presses down with force, invisible but heavy. The atmosphere is not emptiness, it is substance. A sea of gases pressing upon us with the weight of 1,000 kilograms per square meter, and we live at the bottom of this ocean. Air is also music. Every sound you hear is carried by molecules vibrating, colliding, passing energy from one to another. Without air, there would be no speech, no birdsong, no whisper, no symphony. The universe beyond Earth is nearly silent, but here sound is constant. Air is warmth. The greenhouse effect, often misunderstood, often feared, is also what keeps us alive. Greenhouse gases trap part of the sun's heat. Without them, Earth's average temperature would be far below freezing. Our oceans would be locked in ice. Life, as we know it, impossible. Too much greenhouse gas and warmth grows dangerous, but without it at all, warmth would vanish. Balance is everything. The atmosphere is also fragile, thinner than the skin of an apple if Earth were the fruit. Just a narrow shell around a vast world, yet that shell is all that separates us from the vacuum of space, from lifelessness, from silence. Astronauts often speak of the overview effect, the moment when they look back at Earth and see the atmosphere as a faint, glowing line against the blackness, thin, delicate, precious. A reminder that everything we know, every forest, every city, every breath, depends on this slender veil. Air changes over time. Millions of years ago, the atmosphere was very different. The early Earth's air was filled with volcanic gases, carbon dioxide, methane, ammonia. No oxygen, no breath for creatures like us. Then, about 2.5 billion years ago, something extraordinary happened. Tiny organisms, cyanobacteria, began producing oxygen through photosynthesis. Slowly, invisibly, the air transformed, oxygen built up, life adapted, complex animals appeared, and humans, much later, could breathe. Every breath you take is part of this ancient cycle. The oxygen in your lungs may once have been exhaled by a forest or released by plankton in the sea. Inhale, exhale, the planet breathes with you. Air is not endless. Pollution reminds us, smog over cities, carbon rising into the sky, yet air also heals. Winds scatter toxins, rain clears the skies. Forests and oceans continue to recycle, to balance, to cleanse, for now. And so we breathe, each of us carrying the same atmosphere, shared, unbroken. Around the entire earth, air binds us together. You are breathing what others once breathed, what trees exhaled, what ancient animals once released. Air is memory, air is connection. Look up tonight. The sky seems empty, but every star you see, every glimmer of moonlight, passes through this thin veil. The atmosphere bends the light, colors it, makes sunsets blaze with red and gold, makes the sky by day appear blue. Without air, there would be no blue sky, only blackness, even in daylight. Our atmosphere is more than gas. It is color, sound, warmth, breath, life. And as you drift into rest, remember, we live inside a miracle, a fragile blanket that holds us, protects us, warms us, carries our voices and our dreams. The air that breathes, and above it, space, endless, waiting. The moon, silent, watching. It hangs above us, pale and patient, night after night, year after year, always there, always near. It is Earth's companion, its partner. Its pull commands the seas, its glow inspires the heart. Without the moon, our world would be very different. The moon is about 1/4 the size of Earth, not large compared to the giants of the solar system, and yet its influence is vast. Its gravity reaches across 384,000 kilometers of space. Invisible hands tugging at our oceans. Tides rise, tides fall, twice a day, every day, the rhythm of the sea. High tide brings waves crashing against cliffs. Low tide reveals shores, pools, and sand. This constant motion shapes coastlines, carves harbors, and stirs life itself. Many species depend on tides. Crabs scuttle with the retreating sea. Birds feed on what the waves leave behind. Coral reefs release eggs in tune with the lunar cycle. Life dances to the moon's rhythm. The moon is locked to us. It shows only one face, the near side. Its far side, hidden from Earth, remained a mystery until 1959. That year, the Soviet spacecraft Luna 3 sent back the first photographs. Humanity, for the first time, saw what lay beyond. The surface is scarred, craters, basins, plains of dark lava we call Maria. They tell the story of impacts, ancient collisions with asteroids and comets, some strikes so violent they shook the entire moon. The moon itself was born from violence. About 4.5 billion years ago, early Earth collided with a Mars-sized object. The impact tore away rock and molten debris. That debris gathered, spun, cooled, became the moon. Since then, it has orbited us faithfully, a reminder of cosmic chaos and of lasting partnership. Its pale glow has guided humanity for millennia. Before compasses, before GPS, travelers looked up, sailors navigated by the moon, farmers tracked planting cycles with its phases. Poets and dreamers found light in its silver glow. The phases themselves are a cycle, a dance of light and shadow. The moon does not shine on its own, it reflects sunlight. As it orbits Earth, we see changing shapes. Crescent, half, full. Then it begins again, a 29.5-day rhythm. Steady, predictable. Cultures across the world built calendars on this cycle. Rituals, festivals, stories. For some, the full moon meant harvest. For others, it was sacred, a symbol of renewal. And in every era, people have gazed up, wondering. The moon also guards our planet. Its presence stabilizes Earth's tilt. Without it, our axis would wobble wildly, seasons would shift chaotically, winters fierce, summers scorching, life would struggle to adapt. But the moon holds us steady, a cosmic anchor. Even time itself feels the moon's touch. Its gravity slows Earth's rotation, very slightly. A day grows longer by fractions of a second every century. Long ago, Earth spun faster. A day lasted only 18 hours. The moon's steady pull stretched it, a dance of slowing, balancing, changing. Humanity has reached the moon. 12 astronauts have walked upon its surface. The first, Neil Armstrong in 1969. His words, "One small step for man, one giant leap for mankind," carried across the world. For a brief time, humans stood on another world, looking back at Earth, small, blue, fragile. From the moon, Earth hangs in the sky, a glowing marble suspended in darkness. Astronauts describe it as breathtaking. Some speak of tears behind the visor, to see home entire and whole floating in the void, a reminder of how rare, how delicate, how precious life is. The moon is not silent in science. Seismometers left by Apollo astronauts recorded moonquakes, some caused by meteor impacts, others by the tug of Earth's gravity. The moon is not entirely still. It trembles, it shifts. Slowly it drifts away. Each year it moves 3.8 centimeters farther from Earth. Inch by inch, the distance grows. One day, hundreds of millions of years from now, the moon will be too far. Tides will weaken. Eclipses will end. The partnership will fade. But for now, it remains faithful, present. Its glow touches art. Lovers walk beneath it. Poets compare it to hope, to longing, to eternity. In ancient myth, it was a goddess, a hunter, a guardian. In every culture, the moon has meaning. Its light is soft, gentle, a reflection of the sun, yet entirely its own. It does not blind, it soothes, it invites stillness. Even in science, the moon continues to call. Nations prepare to return, to build bases, to mine ice in its shadows, to use it as a stepping stone to Mars. The moon is no longer just a mystery, it is a future. And yet tonight, as it rises over oceans and mountains, it is still the same moon, the one our ancestors saw, the one that pulled at their seas, guided their journeys, lit their nights, silent, watching, patient. It shapes the tides, it steadies our axis, it marks our months. It stirs our imagination, the moon, Earth's partner. And as its glow fades at dawn, another light rises, the sun, endless fire, endless power, a star that gives us life. And so from the moon we turn our gaze to the sun, the solar system, a family in motion, each world circling the sun, each world unique. Together, they move in silence, a cosmic dance that has lasted billions of years. Closest to the sun is Mercury, small, scorched, a world of extremes. By day, the surface bakes at 430 degrees Celsius. By night, it plunges below -180. No thick air to hold the heat, no oceans to soften the shift, only rock, silent, ancient, cratered. Mercury is fast. The fastest planet. It races around the sun in just 88 days, a year shorter than a season on Earth. Time itself feels different there. The sun rises slowly, sets strangely. In some places, the sun appears to rise, pause, and set in reverse, a world where even day and night move to a different rhythm. Next comes Venus, almost Earth's twin in size, but not in spirit, wrapped in clouds thick with carbon dioxide, a blanket of poison. Sulfuric acid rains fall through skies that trap heat in a runaway greenhouse effect. On Venus, the surface temperature never cools, always hot, always burning at 465 degrees Celsius, hotter even than Mercury. Its rotation is strange. Venus spins backwards slowly. A day lasts 243 Earth days, longer than its year. On Venus, the sun rises in the west and sets in the east, a planet of reversal, a mirror world. And yet scientists wonder, long ago, could Venus have been different? Some models suggest oceans may have once covered its surface. If so, it might once have been a world of water, a world not unlike our own. Beyond Venus lies Earth, the only known world of life, blue, green, white, fragile, alive. And beyond Earth, Mars, the red planet, dusty plains, towering volcanoes, valleys that stretch across hemispheres. Once, rivers carved its surface. Ancient lake beds remain. We send rovers to wander its deserts. They search for clues, for water, for fossils of life. Mars is cold now, its thin air unable to shield us, or warm, but in its youth it may have been warmer, wetter, more welcoming. For centuries humans have looked to Mars with wonder. In 1877, Italian astronomer Giovanni Schiaparelli described canali on its surface. Channels, he thought. Mistranslated as canals, many believed Mars was home to civilizations. Stories of Martians filled books, newspapers, and imaginations. Though we now know the truth, the dream of life on Mars still lingers. Then come the giants, worlds too vast to walk upon. Jupiter, the largest planet of them all, 11 times wider than Earth, a world of storms. Its great red spot has raged for centuries, its atmosphere a swirling dance of hydrogen and helium. But Jupiter is not alone. It carries with it a retinue of moons, more than 90 as far as we know. Some are worlds in themselves: Europa with its ocean beneath ice, Io, alive with volcanoes, Ganymede, larger than Mercury, Callisto, scarred with craters, each moon a story, each moon a mystery. Beyond Jupiter, Saturn, the jewel of the solar system, surrounded by rings, bright, delicate, made of ice and dust. Each ring, a countless collection of fragments, some no bigger than a grain of sand, others the size of mountains. They orbit in thin, glittering bands. From Earth they seem solid. From space they are endless detail. Saturn too is rich with moons, Titan with its lakes of liquid methane, Enceladus spraying jets of water from beneath its icy crust, signs perhaps of hidden seas, places where life, simple and unseen, might yet exist. Farther still, Uranus, the sideways planet. It rolls as it orbits, tilted almost completely onto its side. Seasons there last for decades. Methane in its atmosphere paints it pale blue, a world distant, cold and strange. Then Neptune, deep blue, winds faster than any in the solar system. Storms sweep across it at thousands of kilometers per hour. Dark spots appear and vanish in its atmosphere. Neptune is far, faint, but alive with motion. Beyond Neptune lies the realm of icy worlds. Pluto, once called the ninth planet, now a dwarf planet but no less fascinating. Mountains of ice, a heart-shaped plain, and beyond Pluto countless objects drift in the Kuiper belt, remnants of the solar system's birth. For 4.5 billion years, the planets have circled the sun, each orbit precise, each path a thread in the grand dance. Gravity binds them together, a harmony of motion. Johannes Kepler, in the 17th century, uncovered this harmony. He described how planets move not in perfect circles, but ellipses. Later, Isaac Newton revealed why. Gravity, the same force that pulls an apple to the ground, holds the planets in orbit. Simple, profound, the laws of motion written across the cosmos. The planets move in silence, but to us, they speak of wonder. They remind us that Earth is not alone, that we are part of something vast, a system, a family of worlds, each different, each beautiful. At night we can see some with our own eyes: Mercury at dawn, Venus the evening star, Mars glowing red, Jupiter and Saturn steady in the sky. They shine like ancient companions, lights that have guided farmers, sailors, dreamers for thousands of years. And as telescopes grow stronger, as probes journey outward, the dance grows clearer, more detailed, more wondrous. The planets do not rush, they move slowly, steadily, year after year, century after century, always circling, always bound. Their dance continues, and we, tiny observers on a fragile blue world, watch in awe, the planets in their dance, and beyond them, the stars, endless, countless, waiting. Stars, fire without end. They are born in silence, they live in brilliance, and in time they die. Yet at every stage of their existence, they tell a story written not in words, but in light. A star begins in darkness, hidden within immense clouds of gas and dust, known as nebulas. To the naked eye, these regions may appear as faint smudges across the night sky, but within them, gravity is at work. Slowly and patiently, gravity gathers atoms of hydrogen and helium together. Over thousands, even millions of years, pressure builds, temperatures rise, and particles collide with increasing force. Then, something remarkable happens. Nuclear fusion begins. Hydrogen atoms fuse into helium, releasing tremendous amounts of energy. From the silence of the void, a new star ignites. Our own sun is such a star. It is, in many ways, ordinary. A middle-aged, medium-sized star, one of countless billions in our galaxy. And yet for us, it is extraordinary. Its light has burned for 4.6 billion years, long before human history began, and its steady warmth makes life possible on Earth. Every ocean wave, every blade of grass, and every breath we take is sustained by its energy. Without it, our world would be a frozen, lifeless rock adrift in space. The Sun is one star among hundreds of billions in the Milky Way galaxy, and the Milky Way is just one of trillions of galaxies across the universe. Each of these cosmic islands is filled with stars, burning in silence, their light traveling across unimaginable distances. Each star is a beacon of fire in the vast darkness. Stars, however, are not all the same. They come in many sizes, colors, and lifespans. The smallest are known as red dwarfs. They are cool, faint, and patient, burning their fuel so slowly that they can shine for trillions of years, far longer than the current age of the universe itself. Long after our sun has died, red dwarfs will remain, glowing like quiet embers in the dark. At the other extreme are the giant stars. They burn with white or blue light, hot and ferocious, consuming their fuel quickly. These massive stars live short, brilliant lives, sometimes lasting only a few million years. And when they die, they do so with unimaginable force, exploding in a supernova. A supernova can shine brighter than an entire galaxy for a brief moment. In that explosion, new elements are forged. Iron, calcium, carbon, even gold. These elements are cast out into space, seeding the galaxy with the building blocks of life. The iron in our blood, the calcium in our bones, and the oxygen we breathe were all created in the hearts of ancient stars. Carl Sagan once said, "We are made of star stuff." And indeed, every human being carries within them the ashes of stars that lived and died billions of years ago. For thousands of years, humans have looked to the stars not only for survival, but also for meaning. The ancient Egyptians aligned their pyramids with certain stars. The Babylonians charted their motions with precision. The Greeks imagined patterns in the heavens and gave us constellations that we still recognize today: Orion the Hunter, Cassiopeia the Queen, Ursa Major the Great Bear. For the Polynesians, stars served as guides across the open ocean, a celestial map written in light. Long before telescopes, long before modern science, the stars were our companions, storytellers, and navigators. But beyond myths and stories, the stars carry hidden truths. In the 19th century, astronomers learned to study starlight itself. By passing it through a prism, they discovered that stars produced rainbows interrupted by thin, dark lines. Each of these lines corresponded to a specific element, revealing the chemical makeup of stars light years away. This discovery unlocked the true language of stars, a code written in light. From these spectral fingerprints, scientists could tell not only what stars were made of, but also their temperatures, their ages, and even their movements across the sky. Starlight carries more than chemistry, it also carries time. The nearest star beyond the Sun, Proxima Centauri, is 4 light years away. When we see its faint glow, we are looking 4 years into the past. More distant stars carry us even further back. Some are so remote that their light began its journey millions of years ago, long before humans ever walked the Earth. The Hubble Space Telescope has captured galaxies so distant that the light we see today left them billions of years ago, when life on Earth was only just beginning. To gaze at the stars is to gaze into history. Stars, however, are not eternal. Their ends are as fascinating as their beginnings. Some shrink into white dwarfs, small, hot remnants that slowly cool over billions of years. Others collapse into neutron stars, so dense that a teaspoon of their matter would outweigh a mountain. These neutron stars sometimes spin rapidly, sending out beams of radiation like cosmic lighthouses pulsing across the galaxy. The most massive stars collapse even further, forming black holes. These mysterious objects warp space and time, trapping even light within their grasp. Though invisible, they shape galaxies, holding billions of stars in their sway. Our own sun too has a fate. About 5 billion years from now, it will exhaust its fuel. It will expand into a red giant, swallowing Mercury, Venus, and perhaps even Earth. Then in its final act, it will shed its outer layers into space, creating a glowing planetary nebula. At its core, a white dwarf will remain, cooling slowly into darkness. Its story will end, but by then, new stars will have risen, new fires will burn, and the universe will still be filled with light. And so, when we look at the night sky, we are not just looking at points of light, we are reading a cosmic story. Each star is a word, each constellation a sentence, and together they tell the tale of creation, destruction, and time itself. The stars speak, and if we listen carefully, we can hear them whisper that we are part of their story too. The stars burn, their light travels, and beyond them lies the deep black of interstellar space, a place of silence, a place of hidden wonders, and it is there in the quiet between the stars that our journey continues. Nebulas, silent, enormous, waiting. They drift in the galaxy like cosmic oceans, clouds of gas and dust stretching for light years. To the naked eye, they seem invisible, but through a telescope they bloom into color, veils of red, green, blue, wisps of light painted across the dark. Nebulas are the cradles of stars, places where creation begins. Within their cold depths, hydrogen gathers, slowly, patiently, pulled together by gravity, stronger and stronger, until pressure builds, heat rises, a spark ignites, a star is born. It is a process that can take millions of years, from silence to brilliance, from dust to fire. Some nebulas are remnants of death, supernovas. When a massive star explodes, it scatters its remains across the galaxy. Iron, carbon, oxygen, the very elements that make our bodies. These ashes drift and swirl. They become part of a nebula, and from this debris, new stars rise. So every beginning carries traces of endings. Every glow carries shadows of destruction. The Orion Nebula is perhaps the most famous, just beneath Orion's belt, visible even to the human eye. It is a nursery filled with thousands of young stars, some only a few million years old, still infants by cosmic standards. Within its glowing clouds, disks of dust spin around newborn suns. Someday these disks may form planets, rocky worlds, gas giants, moons, perhaps even the seeds of life. This is how our sun began. 4.5 billion years ago, in a nebula long gone, a cloud of hydrogen and helium collapsed. A fireball ignited, and around it, Earth and its neighbors slowly took shape. We are, in every way, children of a nebula. There are many kinds: emission nebulas glowing with the heat of newborn stars, reflection nebulas shimmering with borrowed light, dark nebulas cold and dense hiding their secrets in shadows. The Eagle Nebula holds towering columns of dust. They are called the pillars of creation, immense structures stretching light years high. Within them stars form in silence, hidden inside. When the Hubble Space Telescope captured their image in 1995, the world paused. It was like looking into the womb of the universe, and yet scientists believe those very pillars may already be gone, destroyed by a supernova thousands of years ago, but their light is still on its way. What we see today may be a memory, a ghost. That is the wonder of nebulas. They remind us that space is not still. It is always in motion, always changing. What we see is often the past, still traveling to meet our eyes. For centuries, people looked at nebulas and saw mystery. The word itself means cloud in Latin. Early astronomers thought they were faint smudges on the sky. Only with the power of modern telescopes did we see their true nature, not just clouds, but engines of creation. NASA's James Webb Space Telescope has brought us closer still. Its infrared eyes pierce through the dust, revealing stars that were once hidden. Tiny red dots, scattered like embers in a fire, proof that the universe is still alive with birth. Nebulas are not rare. The Milky Way is filled with them, silent nurseries scattered across its spiral arms. In each, stars are forming even now. Somewhere, perhaps, planets are already taking shape. And maybe far away, a world is beginning that will one day look back at the sky, wondering just as we do now. Nebulas connect us to the beginning, to the cycle of creation and destruction, to the truth that everything we are, our bones, our breath, our thoughts, once floated in a cloud of stardust. The poet Carl Sagan once said, "We are made of star stuff." And nowhere is that more visible than in the luminous clouds of a nebula. Every flicker of light, every star that shines, begins here in the birthplace of light. As we drift from these clouds of creation, we follow the light they send across time, across space, toward the galaxies beyond. For just as stars are born, so too are the great islands of stars, vast, spiraling, endless. And so the journey continues, from the nurseries of stars to the homes they build together, from nebulas to galaxies. Black holes, invisible, relentless, beyond comprehension. They are among the strangest objects in the universe, not because they are rare, but because they are so absolute. A black hole is not truly a thing. It is a place where space itself collapses, a boundary where time breaks. At their heart lies the event horizon, a surface where gravity becomes so strong nothing can escape, not light, not radiation, not even time as we understand it. Once something crosses that line, it is gone forever, lost to the singularity, a point where the known laws of physics no longer apply. Black holes are born from endings, the deaths of massive stars. A star many times larger than our sun burns through its fuel, shining for millions of years, but eventually its fire goes out. Gravity, once balanced by fusion, wins the struggle. The core collapses, matter falls inward, atoms are crushed. In one final explosion, a supernova, a black hole is born. Some black holes are small, just a few times heavier than our sun. Others are unimaginably vast. At the centers of galaxies lurk supermassive black holes, millions, even billions, of times the mass of our star. Our own Milky Way has one, Sagittarius A. A dark giant, 26,000 light-years away, quietly shaping the dance of stars around it. For decades, black holes were only theory. Albert Einstein's equations hinted at their existence, but even he doubted they could be real. Later, physicists like Carl Schwarzschild and John Wheeler gave them shape. They studied the mathematics, saw the predictions, and realized the universe may be hiding monsters. And yet these monsters are silent. We cannot see them directly. They give off no light. They are defined by absence. But when matter falls toward them, a drama unfolds. Gas and dust spiral inward, heating to millions of degrees. This glowing disk, called an accretion disk, shines brighter than entire galaxies. Through this radiation, we catch glimpses of the invisible. In 2019, humanity saw the unseeable. The Event Horizon Telescope captured the first image of a black hole, the glowing ring of light around the shadow of the one in galaxy M87. It was a moment of awe, proof that these giants are real, not imagination, not just equations. Black holes bend space itself, they warp time. To an outside observer, something falling into a black hole appears to freeze at the horizon, stretched endlessly, never quite vanishing. But from within, the fall is swift. Time moves differently near such extremes. A minute for one observer might be 1,000 years for another. This bending of reality is not just science fiction, it is measured, verified. The universe at its edges behaves in ways that defy our senses. And still they remain mysterious. Do black holes destroy information or hide it? Do they lead to other universes? Could they be bridges, wormholes, across space and time? These questions remain unanswered. Some of the brightest minds of our age, including Stephen Hawking, devoted their lives to this puzzle. Hawking radiation, his groundbreaking idea, suggests black holes may slowly evaporate, leaking energy over unimaginable timescales. Even in their silence, they may not last forever. Black holes shape galaxies. Their gravity sculpts the paths of stars, guiding their orbits. In their violence, they may seed creation, triggering bursts of star formation around them. They are destroyers, but also cosmic architects. Imagine standing at the edge of one, space stretching downward, light curving, time slowing. The sky above pulled into strange patterns, as if the universe itself were bending. It is a place no human could survive, yet it is also a place that defines reality. We often think of them as monsters, but perhaps they are keepers of secrets. They may hold answers to the deepest questions we can ask. What is the nature of space, of time, of existence itself? Silent giants, hidden in darkness, yet shaping everything around them. As we move further outward, beyond even the black holes, the universe reveals something larger still, structures that span billions of light years, cosmic webs of galaxies stretched across the vastness of space. The black holes are gateways to mystery, but the universe itself is the canvas. And so we leave these silent giants behind, drifting further into the great expanse, toward the vast web of galaxies that binds it all together. Galaxies, vast, silent, endless. They are the great cities of the cosmos, not made of stone or glass, but of stars, billions, sometimes trillions, each one a sun, each one with its own story. Together they form galaxies, islands of light adrift in a sea of darkness. Our own Milky Way is one such island, a barred spiral galaxy turning slowly in the void, its arms stretched like ribbons, filled with dust, gas, and over 100 billion stars. From Earth we see only a glimpse, a faint band across the night sky, a river of light so familiar yet so vast it defies imagination. Galaxies come in many forms, spirals like the Milky Way with graceful arms, ellipticals, smooth and ancient, filled with older stars, irregulars, chaotic in shape, torn by collisions, each type a different chapter in the story of the universe. And they are everywhere. Astronomers estimate there may be more than 2 trillion galaxies in the observable universe, 2 trillion islands of light, each drifting through the dark. But galaxies are not still. They move. They collide, they merge. Gravity pulls them together, reshaping them over billions of years. When 2 galaxies meet, stars rarely crash. The distances are too vast. Instead, their gravity stirs the gas and dust, igniting new waves of starbirth. Out of collision comes creation. Our own Milky Way is not alone. It belongs to a family called the Local Group. Over 50 galaxies, large and small, bound together by gravity. The largest is Andromeda, a spiral galaxy more massive than our own. And one day, far in the future, Andromeda and the Milky Way will meet. In 4 billion years, their arms will intertwine, their stars will mix, a new, larger galaxy will be born. We know this because of light. Galaxies speak through it. Their light travels across unimaginable distances, carrying stories from the past. When astronomers look through telescopes, I see galaxies not as they are now, but as they were millions or billions of years ago, a cosmic time machine. The Hubble Space Telescope revealed this truth in breathtaking detail. By staring into a patch of sky that seemed almost empty, it found thousands of galaxies, faint and ancient, from the early universe, each one a spark of creation, a glimpse of what existed billions of years before Earth was born. And galaxies do not drift alone. They gather into clusters, massive collections bound by gravity, thousands of galaxies held together, surrounded by vast clouds of hot gas and shaped by invisible dark matter. Beyond clusters, they form superclusters, colossal structures spanning hundreds of millions of light years. Together, they weave into the cosmic web, the largest pattern in existence. Every galaxy is a world of wonders. Some harbor supermassive black holes at their cores, devouring matter and releasing jets of energy that stretch for thousands of light years. Some glow with the light of newborn stars, pink and blue against the dark. Others are quiet, ancient, their star-making days long gone. Our Milky Way, though vast, is only average, yet it is home. Here, in one of its spiral arms, a small star shines, our sun. Around it, 8 planets, countless moons, and us. One small corner of an immense city of stars. Galaxies remind us of scale. They are too large for the mind to truly grasp, yet their beauty lies in patterns we can see. The spirals, the clusters, the streams of light stretching across the night sky. Each one an island, each one alive with billions of suns, many with planets, some perhaps with life. In the darkness between galaxies, space is nearly empty, a great void. Yet, from a distance, the universe glows, not from a single star, but from the combined light of galaxies spread across eternity. We are part of this grand web, a single species, on a single planet circling a single star, and yet tied to galaxies that stretch across billions of light years. Galaxies are both distant and familiar. Distant because we cannot touch them, cannot journey across them. Familiar because we live inside one, and every night it paints its presence across the sky. They are not eternal. Over time, galaxies evolve, collisions reshape them, stars are born, burn and die, black holes feed, then fall silent. The universe changes slowly but always, and galaxies are its markers, silent witnesses to billions of years. As we drift through space, wrapped inside our Milky Way, we are reminded of this truth. The universe is not empty, it is filled with light, islands of it scattered everywhere, waiting to be seen. And just beyond the galaxies, stretching into the deepest reaches of time, lies the afterglow of the beginning itself, the first light, the echo of the Big Bang. From galaxies, we move now to the earliest light in the cosmos, a whisper from the moment everything began. Silence, infinite, endless. The universe is not only galaxies, stars, and planets, it is also the spaces between them, vast reaches of emptiness where light grows thin and silence becomes almost absolute. When we look into the night sky, we see points of brilliance, stars burning, planets reflecting light, galaxies glowing, but what we often forget is this. Most of the cosmos is not light, it is darkness, a great ocean of nothing, stretching farther than we can imagine. Astronomers call it the intergalactic void. These voids are immense, spanning millions of light years. They are places where galaxies are rare, where matter itself seems to vanish. To cross such a void would take longer than the age of the Earth. Within them there is almost nothing to see, almost nothing to touch. Only the faint breath of particles drifting alone. Yet even in emptiness, there are whispers, invisible forces, hidden patterns, dark matter shaping the cosmic web, dark energy driving the universe apart. The silence between galaxies is not truly empty. It is alive with mysteries we cannot yet explain. On a smaller scale, space between stars is called the interstellar medium. It is not a perfect vacuum, though it comes close. A cubic centimeter of this space might hold just a few atoms. Compare that to the air you breathe, which contains billions upon billions. To humans, it would feel like nothing. But on a cosmic timescale, these thin clouds can gather. They can collapse under gravity. They can ignite into new stars. Even in stillness, creation waits. The quiet between is also a stage for light itself. Photons travel across it, unhindered, carrying stories of where they came from. The light of distant galaxies crosses these empty plains for billions of years before arriving at our eyes. We are, in a sense, eavesdropping on the universe, catching faint messages that have traveled through. Silence for eternity. And silence itself has its own meaning. In 1965, scientists Arno Penzias and Robert Wilson pointed a radio antenna at the sky. They were searching for signals. What they found instead was a faint, persistent noise. At first they thought it was static, perhaps from pigeons nesting in the antenna, but no, this was something deeper. It was the whisper of the cosmos itself, the cosmic microwave background, an echo from the birth of the universe, still humming softly across the void, a silence that carries memory. When astronauts travel into space, they describe the quiet as overwhelming. No wind, no waves, no sound carried through the vacuum, only the steady hum of their own spacecraft. Some have said it feels like floating inside eternity itself. In this silence, every breath feels louder, every heartbeat a reminder of life against the backdrop of nothing. And yet this silence is not hostile, it is not cruel, it simply is. The quiet between holds space for everything else to exist. Without emptiness, stars could not shine so brightly. Without distance, galaxies could not drift in their graceful paths. Without silence, the whispers of the universe would be lost. Scientists now listen carefully to this quiet, not with ears, but with instruments. Radio telescopes stretched across mountains, arrays planted in deserts, orbiting satellites high above Earth's atmosphere. They listen to the silence, searching for faint signals, for hidden patterns in the cosmic background. Each hum, each wave of static could be a clue, a piece of the story we have not yet heard. And perhaps somewhere in the quiet, other voices wait. Signals from civilizations across the stars. We do not know. For now, the silence remains, but it is a silence filled with possibility. The quiet between is as much a part of the universe as the stars themselves. It is the canvas upon which light is painted, the stage upon which galaxies drift. It is stillness, but never truly empty. And when we look into the dark, when we see only silence, we are reminded of our own smallness. Earth, a fragile dot. Humanity, a brief spark. Yet here we are, able to listen, able to wonder, able to hear the whispers carried across billions of years. In the end, silence is not absence, it is presence. A vast, steady reminder that the universe is larger than us, older than us, stranger than we can ever imagine. And from that silence, something always emerges. Stars, galaxies, life. Which brings us to the next question. What of life itself? Does the silence between hold voices we cannot yet hear? Beyond the quiet between lies the search for life among the stars. Earth, the blue jewel. Suspended in a sea of darkness, small, fragile, alive. From the farthest reaches of the solar system, it looks like a glowing marble. a swirl of blue oceans, white clouds, and continents brushed with green and brown. Against the blackness of space, it shines with a light that is soft, yet unmistakable. To us, it is everything. In 1968, humanity saw Earth as never before. The Apollo 8 astronauts orbiting the Moon looked back and captured a photograph that would become known as Earthrise, a delicate sphere rising above the barren lunar horizon, oceans glimmering, clouds curling like paint strokes. For the first time, we saw our planet from the outside, and in that image, many felt a sudden truth. Earth is one world, one home. Decades later, in 1990, Voyager 1, billions of kilometers away, turned its camera back toward Earth. What it revealed was not a glowing marble, but a speck, a single pixel of pale blue light, barely visible, suspended in a shaft of sunlight. Carl Sagan called it the pale blue dot. He reminded us that on that tiny speck, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. A planet reduced to a dust mote, yet holding all of human history. Up close, Earth is dazzling. More than 70% of its surface is covered by water. Vast oceans shimmer in shades of turquoise and deep indigo. They move in ceaseless rhythm, driven by winds, by the pull of the moon, by heat from the sun. They are not just water, they are life. Within them swim billions of creatures, from microscopic plankton to the largest animal to ever exist, the blue whale. Above the oceans, clouds swirl in endless motion, white, shifting, reshaping. From orbit, they resemble brushstrokes on a canvas, painting patterns across the planet every hour. These clouds carry water, they carry storms, they bring life to forests, to fields, to deserts, waiting for rain. The continents tell another story. Mountain ranges thrust upward by the slow movement of tectonic plates. Forests stretch across millions of square kilometers, breathing out oxygen, absorbing carbon. Deserts blaze with heat by day and chill under starlight by night. Frozen poles, glittering in white, balance the warmth of the tropics. Earth is not still, it is alive with motion. The ground trembles with earthquakes. Volcanoes release fire from within. Rivers carve valleys. Glaciers grind mountains into dust. The planet is always shaping itself, always renewing. Life here is astonishing in its variety. From the deepest trenches of the oceans to the thin air of the highest mountains, life finds a way. Bacteria, unseen yet countless, thrive in extremes of heat and cold. Plants stretch toward the sun, capturing its light and turning it into food. Animals run, swim, soar, and burrow. Humanity itself is but one thread in this great tapestry. And still, Earth is delicate. Its atmosphere is thin, thinner than the skin of an apple if the planet were that size. Within this fragile shell lies everything we breathe, every sound we hear, every cloud we see. It holds warmth, it filters sunlight, it shields us from deadly radiation. Without it, Earth would be a frozen wasteland, stripped bare by solar winds. Its distance from the sun is just right, not too close, not too far. The habitable zone. Here, liquid water can flow. Here, life can thrive. No other planet we know of shares this balance. From space, there are no borders, no lines dividing nations, no walls, no fences, only the whole, only the blue jewel. Astronauts often speak of the overview effect, the profound change in perspective when they see Earth from above. They describe a sudden awareness of its fragility and of our shared responsibility to protect it. Earth is unique, but it is not eternal. Its systems are delicate, balanced over billions of years. Humanity has become powerful enough to alter them. The atmosphere warms, ice melts, forests shrink, oceans rise. The planet reacts to what we do. And yet there is resilience. Conservation restores what was lost. Technology seeks balance with nature. Humanity too can adapt. The same intelligence that once split the atom and reached the moon can also heal forests, protect oceans, and preserve the fragile air we breathe. Scientists search for other Earths among the stars. Telescopes scan distant systems, searching for rocky worlds in the habitable zones of their stars. Some show hints of water vapor, others reveal atmospheres of strange gases. But none yet are like ours. None with oceans that glitter blue, none with continents alive with forests, none with air we could breathe. For now, Earth is the only world we know with life, the only oasis in an ocean of silence. The blue jewel shines because of its life, Against the silence of the cosmos, it glows with forests and rivers, with storms and cities, with laughter, with voices. Every dawn, every sunset, every beating heart. This is home, the place where stories began, the cradle of all we know. And as we drift further into the cosmos, in thought, in mission, in dream, the blue jewel remains our anchor, a reminder of balance, of unity, of peace. The journey ends here as it began, with Earth, fragile, alive, suspended in darkness, shining with light, a jewel in the infinite,